Hey, what's up everyone? Thank you so much for joining today's webinar. We're here to answer the loaded question of whether or not xApps can actually replace SOLIDWORKS Desktop. So for those of you who've been SOLIDWORKS users for maybe the last 20, 25 years, I realize that is a big thing to try to take on. So if you're curious as to whether or not it's actually possible, stick around to find out. Just a quick intro. My name's Jared. I'm one of the application experts with MLC CAD Systems. Been using SOLIDWORKS for about the past 10 years or so, and this was an intriguing webinar to actually prepare for because, I've been a SOLIDWORKS user for 10 years and trying to determine and decipher whether or not you can actually replace it with browser-based apps. Well, that's a pretty big undertaking. I always like to do a real brief introduction to who MLC CAD Systems is, just for those of you who aren't really familiar. This is where we operate geographically, so you can see we're pretty large in that sense. And we're also pretty large technically as well. We take a lot of pride in keeping all of our application experts, up to speed on the latest and greatest stuff. So hopefully you've got the chance to kind of interact with us and our team, and if not, then hopefully you get that chance in the future. So once again, can xApps replace desktop? That's what we're here for. The first thing we need to do is to actually define what an xApp is, right? They just put this variable in front of app and we're expected to know what it means. Okay. Well, what an xApp is it's completely browser-based, meaning you load it up in a browser, a web browser. So whether that's Google Chrome, Firefox, Safari, it doesn't matter. As long as you have an internet connection, you can run it. It also never requires an install or any type of update. So that means you're always running the latest and greatest version. You never have to worry about planning and downtime and all that good stuff. It also comes built in with cloud data management, so you don't have to worry about saving your files or anything like that on local disks or losing that in the event that you have some type of system crash. And then, of course, we're also hardware agnostic. So that means for you Mac people out there, if you want to run that on your Mac, you can do it. Or you can even run it on your phone or your iPad. All these xApps just need a browser. Now, I say xApps being plural, and the reason I'm saying that is because there's a variety of these different types of applications, and they all are suited to a particular business function or type of design functionality, right? And the benefit behind this, or the idea behind it, is that, if you have a person who's only doing sheet metal work, well, you can just give them that sheet metal app and not have to pay for all the other ones. So that's the idea behind it. Just to briefly go over what these do, xDesign is a parametric modeler. xShape is a freeform subdivisional modeling. By the way, I'm kind of biased. I love xShape. It's really cool. xDefine allows us to do MBD style and 2D drawing type of documentation. xFrame is kind of like weldments for those of you who've been using SOLIDWORKS. And then, of course, we have xMold, which is actually a really useful mold tool. Kind of really simplifies the process of creating molds. So that's just in general, and these xApps, this library of xApps is expanding almost continuously. They're always adding new functionality for them or new applications to do different types of tasks. So now that we've defined what an xApp is, wouldn't it be nice if you could just get all of them in like a big bundle? Well, you can, and that's called the SOLIDWORKS Cloud Offer. SOLIDWORKS Cloud Offer. So this just bundles all this stuff up and kind of gives you similar capabilities to what you would have inside of desktop SOLIDWORKS, except of course it's running in a browser, right? All right, I also wanted to, before we kind of jump into the actual applications and show what those look like, I wanted to give a little roadmap for today and kind of show what we're going to be covering. We're going to start off with doing some part design inside of the xApp called xDesign, and then we're going to document that design using the xDefine app, right? After that, we'll do a little bit of assembly modeling. We'll take that part that we designed and we'll stick it into an assembly. Nothing crazy. We'll use xDesign for that. And then we'll do a little bit of freeform design inside of xShape. Now, I realize I'm only covering 3 of the xApps here, and really we'd have to have a much larger webinar than what we have scheduled for today in order to cover all of them. But this ought to give you an idea of whether or not this is doable, right? And it ought to answer the big question that we have of whether or not we can actually replace SOLIDWORKS Desktop. All right, cool. I'm going to jump into my web browser now. So this is Google Chrome, okay? I'm sure some of y'all are pretty familiar with it. So just a regular old web browser. I mean, I can kind of move this thing around so y'all can see it's just Google Chrome here. And right now I have xDesign loaded on this side with my assembly. I'll kind of maximize that and just kind of show off the interface for a second. Take a look, and by the way, all this is real-time kind of stuff. This isn't doctored up or anything like that. So I want to rotate and just kind of show how smooth this interface is. Like, this is pretty good response time as far as zooming and orbiting around the model. You can see it's somewhat similar to SOLIDWORKS in the form of a feature tree over here on the left side. The command manager has kind of been relocated. It's down here on the bottom, and it's called the action bar now. But it's pretty familiar. You can even display the names for those of you who are kind of not used to the different symbols. But a lot of these features are going to be really second nature to a SOLIDWORKS user. So it's a pretty easy transition there. You can see we're in the assembly environment right now, and I mean, of course, we can push and pull and move these things back around. This is, once again, I'm not doctoring anything up here. This is real type feedback that we're getting. Pretty responsive. Maybe not quite as responsive as our SOLIDWORKS desktop that's been honed to perfection over the past 25 years, but pretty good, to be honest. What our purpose is for, I guess, what our goal is in this particular webinar, what we're going to be doing is replacing this red yoke that's right here that's holding up those two different monitor stands. So this one's kind of overbuilt. It's got a little bit more material than what we really need. And we're going to be designing a new yoke and documenting it, of course. So I'm going to switch over to this other xDesign application window that I have. And I'm going to go ahead and get started with that part design. So we've got our default planes. Those ought to look pretty familiar to those of you who've used any type of parametric CAD modeler in the past. And the first thing we'll do is go ahead and create a sketch on that top plane. Now, for those of you who've been longtime SOLIDWORKS users, you might be happy to know that we have shortcut rings. So these are pretty nice. There was actually a recent update where they rolled that out. So you can just right-click, drag, and then you can kind of go about doing whatever you need here. So I'll go ahead and I'll drop in whatever dimensions we need. I'm just going to start by drawing a couple of circles and doing an extrude. And to do that extrude, I'll go ahead and I'll turn on my command names down here just so everybody can get a little bit more familiar with the interface here. And we'll just click on our regular old extrude. This is just like a boss extrude inside of SOLIDWORKS. Nothing really too crazy there. We even have all those familiar mid-plane conditions and things of that nature that we've grown accustomed to maintain symmetry. So that's kind of nice to have there. Now what I'm going to do is draw up the side portions, the little parts that are going to connect to the monitor stands. And to do that, I'll start off with just drawing a little line here. And you can see how whenever we're drawing it, it brings up the dimension. And that allows us to just key in a dimension and it'll populate it for us kind of right off the bat. The other thing that we can do is we can just click on a line or a sketch entity for that matter, and the dimension will automatically pop up for us. It's kind of grayed out, meaning it's not an official dimension until we click on it. And then we can enter in whatever value we need. So you'll notice as I work through this interface that a lot of the things that I need to do are just within what I like to say arm's reach. Not literally arm's reach, but within a very short distance of where I need to place the mouse to actually make that click. So anytime you can save mouse travel, I think that is really beneficial. There's also built-in shortcuts. So once again, I'm going to reference that line command again, just because it's really commonly used. So if I hit my L key, it brings me directly into that line command. And then I can come in and drop in whatever else I need, right? Sketch relations, also really familiar here. You can hold down Control, select multiple entities, and that flyout or context toolbar pops up, and you can jam in whatever you need. So really, really familiar, and I'm trying to kind of build that in here. That just really familiar kind of stuff here for those of you who've been SolidWorks users. We can also convert entities, so we can borrow geometry from kind of the other stuff that we might have here. So that works pretty readily as well. Oh, I didn't apply one of these here. There we go. Fully defined. Nobody gigged me on that. I was not about to leave that sketch underdefined. Okay. You might also be happy to know that we have the power trim command that y'all might be familiar with. So we can come in and we can trim these things up as needed. And now I have a perfect little profile that I can come in and finish up my extrude with. All right, we'll do this one. We're going to maintain symmetry again and do this extrude for like 30 millimeters. All right, so we're starting to take shape here, kind of coming along. This is starting to look like something that might actually be useful in our actual top level assembly. But one of the things we wanted to do was kind of cut down on some of the material. We had high material usage, and an easy tool to accomplish that with would be the shell command. So I'm sure y'all have used this one before. We're going to go ahead and shell this with a thickness of 5 millimeters just on this outside portion that's right here. Now you may notice that if we shell this with that particular distance, it's going to create an offset right here. And that's not really going to look very nice. It's not going to maintain that wall thickness that's sitting here on the main circular boss. Well, cool thing we have with this shell command in xDesign is to do a custom thickness for a particular face. So we can select this inner face right here and do a custom thickness for it. And we'll do a little bit of math. If you remember, we had a 50 millimeter outer circle and then a 35 millimeter inner circle. So we can do that. So that gives us 15 for the total wall thickness. 15 divided by 2, because we're dealing with a circle, gives us 7.5 millimeters. And if we complete that, we can kind of take a look at this and see if that actually looks proper with our section view tool. So all that kind of stuff, all these tools I'm showing should be super familiar for those of you who've been using SolidWorks for a while. So that looks pretty good now. We might just want to kind of finalize some of the design work on here by maybe adding a couple of fillets. Once again, this is really nice. xDesign does a good job of putting everything within arm's reach. So I can just click on this edge and then just jump straight into that fillet tool. We'll add a little 1 millimeter fillet here. By the way, tangent propagation also works. If I just select an edge, it propagates over there. And of course, we don't want to just click edges. We might want to select complete faces as well. So we can do all of that here in xDesign. So I'll just fillet all this good stuff up, make it look nice and pretty before we kind of move into the assembly modeling area. All right, so that's one side of the component that we have designed up here. What we might want to do now is actually mirror this about itself, because remember, we're kind of designing things symmetrically. So we'll come in and just mirror this entire body. All right, so we've got one more feature that we want to apply to this guy, and this is going to be a little angular cutout along the center section here. So this is actually going to be pretty cool what I'll showcase here. This is actually one area where the xApps have a little advantage over your desktop SolidWorks. So check this out. I'll go ahead and make my little cutout here, and let's get a little axis to revolve this around, right? Because we're going to be making a revolve. I'll go ahead and change this to maybe some construction geometry just for dimensioning purposes. By the way, you might be happy to know that the diameter style dimensioning technique that you have from SolidWorks is carried over here as well. So we can come in and drop in that easy to use diameter dimension. Pop in our angle, and we should be ready to do our revolve. Okay, cool. So, I just went in and I accidentally clicked, and I didn't really do this. I did this on purpose. I accidentally clicked the extrude button instead of the revolve. Some of you might have had some experience in doing this, right? And typically that involves just closing out of the feature and re-entering into the other feature. Well, with xDesign, you have something called super feature, which allows you to just change back and forth between these different feature types, all from within that same menu. So I can just say, hey, I'm going to change this over to a revolve. And you know what? Instead of adding material, it's actually going to be a cut. And then I can select my axis of revolution. And boom, I can go about my merry way. Done deal, right? So pretty cool, I think. The ability to just, it gives you a lot of flexibility, I think, is the primary takeaway there. So let's go ahead and save this guy out. I did mention that we wanted to do a little bit of documentation on this, right? And we're going to do that with a cloud-based X application. So I just hit my X key on my keyboard, and you can see how now I have the ability to switch to any of these X apps. So I'm going to go ahead and open up xDefine. And to define what xDefine is, just to kind of summarize, is sort of like an MBD, so a model-based definition application. But you can also create 2D drawing types from those MBD dimensions that you place in here. Okay, so I'll kind of elaborate a little bit on this. Let me show my command names just so everybody can kind of see these things. The first thing we'll do is make some orthogonal views of our model. And to do this, it's pretty simple. I mean, it brings up all of your standard type orthogonal views. So I'll make a front view. Let's even be fancy. We can change our dimension color to where it's blue. So I'll go ahead and I'll make a front view here. Let's go ahead and make a right view as well while we're at it. And then maybe a top view. I think that'll give us enough context really to kind of cover everything that we need. All right, cool. So we've got all of our views created now. So the next step in this process is going to be just applying the actual annotations that we want to have in this model. So in this case, pretty straightforward, just like dimensioning in a normal type of environment that you're probably pretty used to. So we can call out, you know, any type of diameter style dimensions. I mean, I don't want to beat a dead horse as far as calling some of these things out that are a little bit, you know, less than exciting. My primary purpose here is just to kind of showcase what the capabilities of the software are, right? We also have some geometric tolerances of capability. So like if we wanted to call out this hole right here being, I don't know, concentric to within a certain value, we can jam that in here and just reference whatever datum we might need. All right, cool. So I have done enough work on that particular view. Maybe let's just add one more dimension to the front view just for some context here to show our overall height. And then we'll move into the 2D type of annotations that we have the ability to specify here. And those are pretty cool as well because I like to kind of say that xDefine gives you maybe the best of both worlds in the fact that you have MBD and you also have drawing capability. Now, are your drawings going to be quite as fast as using desktop SolidWorks? This is maybe the one area where I would actually I'd pick desktop SolidWorks to kind of reign supreme over this, just because you're going to get a little bit more responsive. But I think within the next couple of months to maybe a year or so, this is going to be super competitive and really have a lot more capabilities. Because remember, these are getting updated. These apps are getting updated very, very regularly. So now that we have our annotations placed in here, of course, we could just continue to use this. We could use our model-based definition, just flip back and forth between whichever views we have to get the information we need. So that's completely doable. But, you know, I realize that a lot of people still use 2D types of drawings and need to communicate that with people. So we can also do that. Here I'll go ahead and just create a sheet. We can give this a name. This will be our new yoke. You can customize the formats and the different layouts if you need to. I don't know. Let's just go ahead and make a portrait, maybe A4 size, just to keep things simple here. You do have the ability to enter in information into this table if necessary. And of course, we can also add the different views that we have. So I'm going to go ahead and add that front view that we created. And we can do this just by dragging and dropping. So that'll pop in right here. We also need to show our top view. And now we can use this to communicate what our design intent is and how this thing needs to be manufactured. One way to share that, by the way, is to come over to our tools area and we can set up a 2D output. So from here, from this 2D output, basically what we're doing is we're PDFing this document, and we can either save that locally or to our 3D drive, which is one of our cloud data management options. And you can save this as either a 2D or as a MBD style of PDF. So like I said, kind of the best of both worlds, right? I'm going to give this a name. I'm just going to keep this saved locally just so I could show it really quickly. And this is what this will look like for you. So you can take this and send it and share it to anybody. Once you fill in your title block information, this will look just as good as really any other drawing that you might have at your drawing tool that you might have at your disposal. So I'll go ahead and I'll save this dude up. And now we need to do a little bit of assembly modeling, right? So what I'm going to do is minimize this pane over here, and then we'll come over and maximize our assembly. So let's jump right in. We've already taken a look at this assembly and kind of orbited around and shown some of the functionality here. But what our primary goal today is to replace this yoke right here. So anybody who's replaced components in an assembly understands that, well, half of the battle is actually finding the component that you actually want to replace. So the platform makes this really easy, and this is actually an area where I feel that X applications shine, is because you can search and find exactly what you need very, very quickly. You saw how fast that happened? That's because we're searching through a database. We're not hunting through some big network drive that takes forever to search through. So we can then select our component, which we found very, very quickly. We can take a look at it and validate and make sure that's what we're actually looking for, and then go about our replacement. Now, those of you who are familiar with working inside of an assembly and doing replacements like this know that we're going to break some mates, because the mate references are going to be kind of screwed up in this particular because of this, right? So we need to cycle through some of these components here and actually repair those references. And xDesign makes it pretty functional to do this. So we get like the little highlight for what it's looking for, and then we can select the component or select the reference on our new component that needs to be attached to. So really pretty straightforward to do these types of component replacements. And I think that looks pretty good. Our model got a little bit cattywampus right there, but we'll show how we can kind of fix that. So I think that looks pretty good here. I'm going to just rotate into a normal manner to kind of do a little bit of a rotation, kind of clean that up a little bit. All right, I think that looks a little bit nicer. Cool, so there's our monitor here, our monitor stand. And you might notice that we've got a little bit of a problem that's sitting right here. This new yoke that we made is a little bit wider. So we actually need to make a change to one of our other components. And we can do that on the fly with xShape. So we can make these real-time types of adjustments here pretty easily. So I can just come in and adjust whatever that gap distance is to whatever value might be needed. And just like SOLIDWORKS, sometimes you have to kind of rebuild or refresh. We can do that inside of xDesign as well. And switching back and forth between editing components in context and flipping back into the actual top-level assembly, just as simple as double-clicking on these components inside of the design tree. So they make it really pretty simple. So as you can see, assembly modeling, pretty straightforward and easy to do with xDesign. And what I'm about to show is actually my favorite application. This is going to be xShape, which is the subdivisional modeler. And this is really an area where these xApps actually have a leg up on SOLIDWORKS. I hate to admit it, I've been a SOLIDWORKS user for 10 years, but you know what? It's actually true. The sub-D modeling is pretty fun. So let's take a look at what that looks like. what we're going to do is actually switch into our xShape application. So we'll go ahead and make that switch real quickly. Once again, I'm keeping all this real. That was a real-time type of switch. So that was what, like 2 seconds? Not really a whole lot of lag here, as you can hopefully see. And what we're interested in doing is creating the base for this monitor stand. You can see how we've got a little bit of help from our graphic design team. They've actually added in some sketch pictures. So you can use sketch pictures in any of these xApps as well, if you're used to doing that in SolidWorks. And we'll go ahead and we'll actually create a subdivisional model that I've already have dropped into the assembly here, but this is going to be to cover up this monitor stand base. So here we have the subdivision tabs are a little bit different than anything maybe that you've seen in the past. If you're really interested in xShape, I actually have made some other webinars in the past that really go into more detail about what you can do with the software. So definitely check those out or reach out if you're curious about getting more info on that. But basically you start off with dropping in what we call a primitive, which is just a shape that's been subdivided already. So we can drop these in, we can control how many subdivisions are actually present. And we can kind of rotate around here. And we can even scale this before we actually confirm the drop of this primitive shape. So we can scale this up or down, or however large we actually want this to appear. So I'll pop it in somewhere maybe in that range right here. And we could probably shrink this guy down a little bit too, just by pushing and pulling on these arrows. So this happens pretty smooth. And by the way, you might look at this and think, man, I wonder what the learning curve is on this particular app. I would say this application is so intuitive that you could probably learn to use it effectively in, I don't know, maybe a couple of days. Like it's that intuitive. With a little bit of training, like you're up and running really quickly. So I'm going to go ahead and I'm just going to push and pull this to where it matches our sketch pictures that our graphic design team gave us. But one of the things that I might want to do is turn symmetry on. So if I want to be symmetrical about a particular plane, well, I can turn that on, and then any of the stuff that I move on one side of that plane is also going to move on the other side. So it makes it super easy to maintain those symmetrical types of designs. And then from there, I just select these points or faces or vertices, whatever have you, and I just push and pull them into position. So it's like you can't get much easier than this. That's why I said at the beginning of this that I really like this tool, because it's actually fun to kind of do work in here. Oh, I flipped around the incorrect way here. Sorry, guys. Get into a better orientation. Now, by default, all of these faces and edges are C2 continuous. So this is great for any type of consumer product design that you might want to be doing. But in the event that you need to crease those edges and make them to where it's a hard edge, you can do that as well, just like I did here. So that works out pretty nicely. You notice that we added and controlled the amount of subdivision faces whenever we were working with this. You can also remove that as you're working. So I can come in and delete any of those faces or edges kind of as needed. Now for this top portion here, what we want to do is actually control how those are angled. And one of the cool ways you can do that is by using this align by line. So you can select all those edges and then they're all going to kind of line up with one another, and you can push and pull as needed to get them into the proper location. So I think this looks pretty good here. Maybe we'll leave that alone. Kind of re-examine things, make sure it looks pretty good. All right, cool. Now, if you're going to do any type of injection molding, you're probably aware that making sure you have draft on your components is very, very important. And you can see here we can quickly turn on draft analysis to where we can come in and move any of these faces to where we can modify that and see the results in real time. So we're getting rid of those undercuts that are right there. And we can see the results in real time, making sure that this is actually something we can manufacture with the particular injection molding process that we have. So pretty Pretty first class right there, if you ask me. All right, so this is looking pretty good here. We've got another primitive that we need to drop in here, just another shape that's going to be that little kind of bulge that's sitting right there. So I'm going to go back to my subdivision, and we're going to drop in another cylinder here. So I'll place this one kind of as shown. Maybe we'll cut down on the amount of cylindrical subdivisional faces we have, and we'll shrink this thing down a little bit. All right, so that looks pretty good. To get a little bit more clarity, we can actually come back and hide the previous subdivision surface that we worked with. That way we can see things a bit more clearly. And up until now, all that we've done is we've kind of pushed and pulled stuff until it's approximately at the correct location. And you may be wondering, well, you know, my processes that I follow, I need to be really precise. You know, I'm a precise guy, or a precise kind of girl. Well, what you can do here is you can actually be very precise with this tool if you need to. So I can come in and scale by a particular dimension. I can say, hey, I want from that point to that point right here. I know that needs to be 60 millimeters across, and I can hit my scale key, and that'll pop it into that particular. It'll pop it into that particular dimension. So really pretty useful tool right there to be able to adequately size things for you. I'm going to go ahead and move this up and just position it a little bit more. I think that looks pretty good though. So we'll go ahead and we'll hop out of that subdivision surface that we were working with there. And right now we have two different bodies that have been created. So for those of you who are familiar with multi-body design, you can do that inside of these xApps as well. And what I'm going to do is actually flip back over into xDesign, and we are going to combine those. So we have the ability to do advanced types of features like this. I can pick on those two different bodies and just select them and say, hey, I want to add these to each other. Boom, done. Now from there, we can doctor up this design a little bit more. I'm going to go ahead and add a little fillet just to make this look a little bit nicer. And then since this is actually a base that's going to be covering this thing, what we need to do is shell it out. So I'll go ahead and I'll shell this thing out to a value of maybe 1. Turn on our tangent propagation and click OK. And now our design for that little monitor stand base is pretty much complete. And I just want to point out the fact that we were able to make something super smooth and curvy and flowy like that very, very rapidly using that xShape tool. And that's, like I said, that's an area where I think we actually have a little advantage over SOLIDWORKS when using these xApps. Like, check that out. That just looks really cool, and I made that in like 5 minutes. That can really expedite some of these design processes whenever you need to leverage particular, you know, continuous, smooth, and flowy, complex surfaces like that. All right, so that pretty much sums up our xApp demonstration that we had. So really what we need to do is answer the question of, can xApps replace desktop SOLIDWORKS? Well, to answer that question, I'm actually going to quote an ancient philosopher, Socrates. It depends. I know some of y'all are questioning whether or not that's actually a Socrates quote, so I found that online. Pretty sure it's true. But really, it does. It depends. It's just like all complex questions in life, right? It's going to depend on a variety of factors. So really what I want to do now is kind of dive into what type of business model these xApps are going to suit. Which ones they'll suit best, or if you'd be better off going with desktop SOLIDWORKS. And really the areas where the X applications shine, or if you need to be hardware agnostic and you hate doing installs and updates, because you never have to mess with an installation whatsoever. You never have to update it, right? It's always running the latest and greatest. You can run it on your Mac, you can run it on a PC, on your Chromebook, on your iPhone, on your Android. It doesn't care. It just needs a web browser. The other area is built-in data management, and that's somewhere that 3D Experience SOLIDWORKS can also shine. 3D Experience SOLIDWORKS is that connected type of SOLIDWORKS, still runs on your local desktop, so it's your SOLIDWORKS you know and love, and it just gives you cloud data management. Now, the other area is I already mentioned this, the ability to work across several different computers or devices. And of course, you can do that with 3D Experience SolidWorks and Desktop SolidWorks, but it's Windows only. With this, it doesn't matter. It's any device. Another area would be if you don't have an IT department, and maybe you don't even know what IT stands for. Well, in that case, you'd probably want to go with some of these xApps for your modeling needs. And just as a side note here, if you're used to using Desktop SolidWorks and you don't have an IT department, well, MLC also offers dedicated cloud servers where we basically function as your IT department, handle that server for you, and create connectivity through either site-to-site VPNs or through a remote access VPN. Now here's where we get to the point where xApps might not be a great fit for you. If you're still doing a lot of high volume 2D drawings, you can still do them with the X applications in the cloud. They're just not quite as fast, and you might not have as customizable of an interface. So 3D Experience SolidWorks or maybe Desktop SolidWorks would still be the best bet for you at that point. The other areas are if you use extensive amounts of third-party add-ins, those aren't supported on either the xApps or the 3D Experience SolidWorks. Or if you're leveraging the API, that's another area. And then, of course, if you ever need to do any type of work that is offline. So Desktop SolidWorks, you don't need an internet connection. You can run on kind of private networks if you need to. Whereas, of course, the xApps and 3D Experience, you still need to have that internet connectivity. Although 3D Experience SolidWorks has an offline mode that's going to be coming up really soon. So hopefully this has been helpful and allows everyone to have kind of an easy to use guide. If y'all do have questions, we'd be happy to answer them. And I hope y'all have a great rest of your day.